Welcome and good morning or good afternoon or good evening to my presentation about food packaging in the circular economy. I will focus on chemical safety aspects for commonly used materials today. So first of all, let me introduce the Food Packaging Forum. So the FPF is a foundation and it's mainly dealing with science communication. So the topics we're talking about are food contact materials, the chemicals these FCMs are made of, migration of chemicals into food, and effects of these chemicals on human health. The FPF has been founded in the year 2012 in Zurich, and it is governed by a foundation board consisting of scientists and communication experts. The FPF is financed by donations, and here you see our team, which is also completely located in Zurich. What are we doing at the FPF? So let me give you a short overview. So we are publishing daily news on the topics I've mentioned before: food packaging, food contact materials, human health, everything which we judge to be important will be can be found on our news. Then we send a newsletter twice a month with a selection of important news. We provide background information on the topics. So we have a quite simple fact sheet explaining the concept of chemical migration and the effects of food contact chemicals, which may be found on human health. Then we have background articles, which are a little bit more detailed. We have in-depth dossiers with a lot of references on certain food contact chemicals, on certain food contact materials, on topics such as plastics recycling or biocides or the threshold of toxicological concern, or the latest dossier which we have published is on non-intentionally added substances. And we also contribute to scientific publications, and there you find the links on our website too. We organize an annual workshop and webinars, and the recordings of all presentations can be found on our website. All information is freely available, and you can access it via the FPF website anytime you want. So now let's start with the circular economy. Here you see an illustration, one of many, explaining the circular economy, and you see that the most important thing is that all materials and products we are using shall be kept in a circle. But what is also important is that all the inputs shall be minimized, so any energy and also raw materials shall be minimized as much as possible, as well as emissions, so anything which gets out and may end up in landfill shouldn't be there. So the European Commission has listed the following points as of central importance for the circular economy. So it says that the value of products and materials shall be maintained in a circle, waste and resource use shall be minimized, areas of action have been defined by the Commission, such as the product design, so one should start at the beginning to think whether a product can be kept in a circular economy or not. The same is true for the production process during consumption, and last but not least, waste management is a very important area of action. Additionally, different sectors and materials face specific challenges, and we would say that also food packaging belongs to these materials, which is highly difficult to keep in a circular loop all the time. So that's one reason for this presentation, and I hope I can provide you with some insights here. Let me go some years back into the year 2015, when the EU published an action plan for the circular economy with the title Closing the Loop. And there are different areas of actions have been defined. You see them here in these boxes. And some of them I've mentioned before, such as product design, production process, consumption, waste management. And again, some more areas have been defined as priority areas, including plastics, food waste, critical raw materials, construction and demolition, and biomass and bio-based products. In the coming slides, I will mainly focus on waste management and plastics, although the other areas may be of similar importance if you talk about food packaging in a circular economy. So in the year 2018, you already see it here, the circular economy package with certain key documents has been published by the Commission. And it starts with the EU strategy for plastics in the circular economy, and then another communication document. The interface between chemical product and waste legislation has been published last year. A draft directive on the reduction of the impact of certain plastic products on the environment. Most of you have heard of that, I guess. And some more documents, publications, measures have been published last year. I have added some more things to this list. Does it come now? Yes. So last year also the waste legislation has been revised. And just a few days ago, a circular economy for plastics, a document by DG, let me check my notes, Research and Innovation has been published, and an implementation report showing the progress has been published just today by the Commission. I will provide you with some more details on these 5 areas or 5 documents or measures. Let me start with the European Strategy for Plastics in a Circular Economy. The document has been published in the beginning of last year, and it identifies key challenges. And some things which were listed here are the total increase in global production for plastics during the last years, then followed by the loss of value if you use the plastic packaging especially, then after a very short time of use, the main value of this packaging is lost. And another example of the key challenges is the plastics in the ocean. The document provides a vision for a circular plastics economy. For example, by the year 2030, all plastics packaging placed on the EU market shall be either reusable or can be recycled in a cost-effective manner. And more than half of plastics waste generated in Europe is actually recycled also by the year 2030. That's the vision. To turn this vision into reality, the economics and quality of plastics recycling shall be improved. Plastics waste and littering shall be curbed by prevention, addressing biodegradable plastics and microplastics. Circular solutions shall be implemented, and harnessing global action would be another measure to turn this vision into reality. As I've mentioned before, just a few days ago, a report by DG Research and Innovation has been published, and this one provides much more detailed information and insights from research and innovation to inform policy and funding decisions to handle plastics in a circular economy. So you can find that online. Now I switch to another communication document published last year, which addresses the interface between chemical product and waste legislation. Here the public consultation has just finished, and it provides you with information on the presence of substances of concern. No, that was wrong. So in the document, it is said that The information on presence of substances of concern are not readily available to all these people who handle waste and prepared for recovery. And of course, waste may contain substances that are no longer allowed in new products, so this has to be addressed if we keep the waste in the circle. And the current rules in the European Union on end of waste are not fully harmonized, and this makes it uncertain how waste can become a new material and product. So the current rules to decide which wastes and chemicals are hazardous are not well aligned, and this affects the uptake of secondary raw materials. So this document mainly identifies challenges which need to be addressed in future. Now I come to the draft directive on the reduction of the impact of certain plastic products on the environment. It aims at reducing plastic waste by transitioning to reusable products, and this shall be achieved by banning plastic cutlery, plates and straws, polystyrene food and beverage containers, oxo-degradable plastics, plastic cotton bud sticks. Then furthermore, the use of plastic food and beverage containers shall be reduced as much as possible. And the directive identifies binding targets of at least 25 and 30% of recycled PET and beverage bottles, which shall be achieved by the years 2025 and 2030. Last year, the waste legislation has been revised, which is also affecting the handling of packaging and food packaging waste. Here you see an overview. So there have been already several directives regulating the handling of waste in the EU, and 4 amendments have been published last year. And I will mainly focus on the first 2, so the Waste Directive and the Packaging and Packaging Waste Directive, and the amendments. I will start with something which is already quite old, so the waste hierarchy, which is defined in Article 4 of the Waste Directive from the year 2008. And there it already says that we should try to prevent waste, so we shouldn't produce any waste if possible. If there is any waste, it should be prepared for reuse. Then, if this is not possible, recycling is the next option, followed by recovery, for example, energy recovery, incineration. And last, we could dispose the waste if no other of these options are feasible. In the amendment, the recycling targets, which have already been there in the 2008 directive, they have changed and increased. So now, by the year 2025, all waste materials need to be recycled to a higher extent. And by the year 2030, these numbers even increased more. If you compare the numbers which are listed here with the current recycling rates, you see that for some materials, the recycling rates are pretty good already. For others, especially plastics, there's still a gap between the current rates of the year 2016, for example. There is a little bit more than 40% of plastic waste recycled, but within the next 6 years, it needs to be 50, and then even up to 55 by the year 2030. These targets include reuse, so that's important because, as you have seen before, reuse would have a higher priority than recycling. Then the Packaging and Packaging Waste Directive also talks about non-toxic material cycles and hazardous substances. If you think about this, and I've said it before, if you keep materials in a loop, of course, you may also keep the hazardous substances if you have used them some time ago. So according to this amendment, it's necessary to ensure sufficient information and/or communication about the presence of hazardous substances and substances of very high concern throughout the whole life cycle of a product. And the coherence among the law of the Union on waste, on chemicals, and on products needs to be improved. And as a consequence, in July 2018, ECHA announced the establishment of a new database on the presence of SVHCs in articles by the year 2021. Now I will stop talking about all the detailed legal measures, and I will provide you with some numbers on packaging waste to get a feeling what we are talking about. So in the EU, in the year 2016, all inhabitants have produced 86.7 million metric tons of packaging waste. So that's almost 170 kilo per inhabitant. And if you look at the materials, you see that the biggest part is paper and board, followed by plastics, glass, and then wood and metal. I also found some numbers for Germany, which are even higher. So there, each person produced 220 kilogram of packaging waste. And what is interesting, here you see how this packaging waste, or what it was used for. So if you look at food and beverage packaging, you see that this is more than half of the total packaging waste. So more than 60% of the packaging waste produced in Germany is used for food and beverage packaging. So you see, if we talk about packaging waste in a circular economy, it's quite an important number and important amount of material we are talking about. So let's combine food packaging and the circular economy. I've said in the beginning that in a circular economy, the value of products and materials needs to be maintained and waste and resource use should be minimized. To achieve this, for food packaging, there are mainly three possible actions. So we can reduce it, we can reuse it, or we can recycle it. Everything else is less favored, and I just don't list it here. The challenges are diverse, and many of them. You see, we have to consider energy use if we talk about these actions. Waste management, I've talked about it before. Something which is highly relevant and didn't appear previously is food waste. Of course, if I change something in my packaging, I may reduce the packaging or improve it somehow or change it, but maybe I produce more food waste, which is of course not what we are aiming for. Then the legal requirements have to be met. Consumers have to accept it and maybe also help to achieve these improvements or any improvements. Safety issues need to be addressed. And last but not least, of course, economic considerations are highly important. So let's have a look how we could reduce food packaging materials. There are completely different ways. So one could start to avoid them as much as possible by buying food on local markets, in zero waste shops, bringing own containers for bulk food, reducing the consumption of highly prepared food, and so on. Then another way is to use lighter materials. Then, of course, I also reduce the total amount of food packaging. And one example is the use of PET bottles, which are getting thinner and thinner over the years for many beverages. And then also to use, for example, multi-layer material instead of monolayer materials, and there I can use less material in the end. Each of these options poses different challenges. So, for example, the food waste and safety issue could be interesting if you try to avoid packaging, because usually food is not very durable, and if I don't package it very well, it may be spoiled or may be spoiled more easily, and the safety may be reduced. That shouldn't be the case, of course, because we don't want to waste food, and the safety should be as high as possible, the microbial safety. On the other hand, maybe you have less chemical migration if you use less packaging, so the chemical safety may also change if you don't use much packaging or if you use big packaging. Then consumer acceptance for all these three, or especially for the first two, consumers need to accept that they have to change their behavior. If they go shopping, they need to bring their containers. If they buy very thin-walled PET bottles, they may squeeze them more easily and it may not be as nice. So all of it has to be accepted by the consumer. Waste management is especially important for the lightweight bottles because there is a report telling that these bottles are more difficult to separate from other plastic waste. So if you want to recycle PET bottles, which is usually rather simple, this may be more difficult if you have very thin-walled bottles. And also if you change your material from monolayer to multilayer materials, of course, you cannot recycle multilayer materials as easily as monolayer materials, so the waste management is more difficult. And also here, the economic considerations play a role. Now let's come to the reuse. That is only possible for some materials. So you cannot reuse all packaging materials, but of course there are well-established systems, deposit systems where, for example, glass bottles are reused, and there are maybe newly developed ideas where people try to support or to introduce reusable coffee cups, for example, or reusable takeaway containers if you go or if you want to buy your lunch at a restaurant and don't want to use one-way containers. Here the energy may be a challenge because you may have longer transport ways and use a lot of energy for cleaning, and safety may be an issue, especially for the coffee cup or the takeaway containers, because they have to be cleaned, of course, very well. Consumers have to work a little bit more if they want to go for reusable systems. They may have to bring bottles back or takeaway containers back. And also here, it would change, or it would require a change in the whole system, and that, of course, needs to be considered whether that's economically feasible or not. Now let's come to the mostly discussed topic, recycling. And there I stopped. So I found these pictures for the different food contact materials: glass, metal, plastics, paper and board, multi-layer materials. And then I thought, but what is recycling actually? How is it defined? And I found a general definition which is quite strict, but I found it very useful because this could be one way to recycle materials. And it means recycling, according to this definition, means that a used product is converted back to raw materials, allowing the repeated making of the same product over and over again. So it's not only one cycle, but it means I recycle many, many times. Then the recycled materials should provide the same quality of the product without degradation of properties. And the third point, no accumulation of contaminants or toxins in the multiple recycling loop shall occur, because this would make the secondary product less safe. So this is one, not a legal definition. You find the source down here in the link. But there is, of course, also a legal definition. And according to that, recycling is any recovery operation by which waste materials are reprocessed into products, materials, or substances, whether for the original or other purposes. And it's not very specific, so you can produce anything else from your starting waste material. I made a small illustration for this. So according to the strict definition, it would mean I have many circles of my products and I can make the same product over and over again. The legal definition would also include something like this. So I have my food packaging waste, and maybe some plastic ends up not in a new packaging, but in a flower pot. According to legal definitions, this should never be recycled into any food packaging again, but it may be recycled into something else. This would still be something according to the legal definition. And just recently, I found a quotation of Björn Hansen, the executive director at ECHA, who said that currently the materials we use today are not circular, they are linear with a few loops. And I think that's a problem. And we need to think about this in future a bit more to achieve all the goals we have defined in the legal texts before. And something which I find very interesting to consider are the so-called permanent materials. So there is also a definition for these materials. And according to the definition, a material is defined as permanent if its inherent properties do not change during use and through solid-liquid transformation. It can revert to its initial state. This is the case when the material consists of a basic component, which is either a chemical element or robust chemical compound, making repeated use and recycling possible without change of inherent material properties. Okay, that was rather difficult now. I've separated the 5 materials which you have seen before now into permanent and non-permanent materials, and that's maybe a little bit more easy to understand. And it means that glass and metal are permanent materials because you can melt these 2 materials over and over again. And you may need to add a little bit fresh or virgin material, but you can recycle aluminum, for example, or steel or glass many, many, many times. In contrast, if you look at plastics or paper or even multilayer materials composed of plastics and paper and maybe even aluminum, there you can recycle, but you need to add virgin materials or the number of loops is really restricted. So if you talk about recycling, again, you have certain challenges. And one is the safety. For permanent materials, this is not such a big concern because any organic contaminant you have in the permanent material usually burns during heating and disappears. On the other hand, non-permanent materials may have big safety problems after recycling because they may absorb chemicals and still keep them and release them in the next round. Or they may change their properties during recycling. So safety is a much more important issue to look at when you talk about the recycling of non-permanent materials. Then, of course, if you want to recycle, you need to have a very good waste management system in place to be able to separate all the different materials according to their properties. And for glass, you may talk about different colors. For metal, you, of course, have different types of metals. Paper has different qualities. Plastics, you have a diverse range of plastics, which needs to be separated because they can heavily disturb each other during recycling. And multi-layer materials are difficult to recycle anyway, but of course, you can at least get something out of multi-layer materials if you talk about recycling. Whether you're able to use non-permanent materials for food contact materials, again, is another question, and I will address that later on a little bit more. Consumers need to support all these waste separation, and often it's not economic to use recycled materials because the prices are too low, and it's cheaper to use virgin materials instead of recycled secondary materials. Now I have an overview how different stakeholders try to work towards a a circular economy. There are many different current initiatives going on, and these are just some examples. I won't go into the details, but so there are probably many more examples out there. These are just some. Now I come to the last part of my presentation, and there we'll mainly focus on a publication which which was released last summer about food packaging in the circular economy, and there we have analyzed the chemical safety aspects for commonly used materials. And here you see the 5 types of materials which we looked at. It's plastics, paper and board, multilayer, multimaterials, metals and glass. And the focus is mainly on recycling, because that's the topic which is mostly discussed at the moment. And I think right now we need to make the right decisions how to produce our materials that we are able to recycle them safely in future. So let's start with plastics recycling. To give you the legal background, in Europe there is a Commission regulation from the year 2008, and there it is defined that all materials used for mechanical recycling must fulfill requirements for plastic FCMs. So we are not allowed to use any other plastic products to produce new plastic packaging. All recycling processes need to be authorized by the Commission. In contrast, in the US, one can obtain a favorable opinion in the form of no objection letters after submitting a dossier to the FDA, but this is not a formal requirement. There are certain challenges, I've mentioned it before, if you want to recycle plastics, and that's mainly because of the physical chemical properties of these materials. Then it's another problem that there are many different plastic polymers out there and they're not all compatible. So if one mixes them during the recycling process, it may be a big problem in the end. Then, as a consequence, multi-layer plastics are hard to recycle because they usually consist of many different or several different materials. And so it becomes very difficult to recycle plastics into new food packaging. It may be much easier to recycle it into anything else, but for food packaging, it's really difficult. So if you look at this example, I've shown you before that PET recycling processes, there are many, and it obviously works. You can buy recycled PET, you can buy recycled PET beverage bottles. That's more or less a loop. Maybe not many loops, but you can separate PET bottles and recycle them into new materials. But for polypropylene, for example, there are many more challenges. So maybe one day we can buy recycled polypropylene food trays and return them. Maybe they are possible to clean and recycle. For polypropylene, this is more difficult. For black material, this is more difficult because it's more difficult to separate it from the waste stream to identify the polymer. This is not as easy as it is for transparent materials. And of course, you can also find, for example, polypropylene, which is black, which was not used in food contact, which of course should not be introduced into new food contact materials in the end again. So this shows only some very few problems which may occur if you talk about food packaging recycling in the strict sense. There are always typical contaminants popping up if you talk about plastics recycling. One group of contaminants are the flavor, aroma, and odor compounds. Then you have oligomers, monomers, and derivatives, which may already appear during the production of virgin materials, but they may also be a degradation product during use or during recycling. Then there are additives and the degradation products. Most plastic materials require the addition of additives to be stable and usable for a certain period of time. Some of these additives change during use on purpose. So they're designed to change, to be oxidized, for example, and they remain in the recycled material. So examples are UV absorbers, antioxidants, and also plasticizers may remain. Then recycling streams may be contaminated with non-food grade plastics or plastics which has been misused by the consumer, for example, bottles containing some solvents. And inorganic elements, heavy metals, may accumulate in plastics after recycling. The sources are not always clear, but they find their way. And for all these examples, you find more detailed information in the paper. So especially you find a lot of references where you can have a closer look. Now let's quickly talk about paper and board recycling. So that's, of course, established in many countries, and the recycling systems are used and exist. Unfortunately, maybe because it is used for so long already, there is no sorting into food grade and non-food grade materials. On the other hand, there are up to 10,000 chemicals used in printed paper and board, and they are also still present in the recycling stream. Furthermore, the low barrier properties promote migration from and through paper and board easily absorb contaminants. So that's why recycling of paper and board and using this recycled material for new food packaging is very difficult and found its way into the media during the last years again and again. And typical contaminants, you have heard of them for sure, are the mineral oil hydrocarbons, bisphenols, phthalates, diisopropyl naphthalenes, photoinitiators, inorganic elements, again, heavy metals, and many others. And for many of these groups of contaminants, you know the sources, you know why they are there, but it's hard to really avoid them. And one needs to handle them to avoid the migration of these unwanted chemicals in the food. So possible measures to avoid such migration of chemicals is a very strict ban of recycled paper and board in contact with food. And for example, in Switzerland, it is regulated like this. So it's not allowed to use recycled paper and board in direct contact with food. Then one could include functional barriers, internal bags, barrier layers, or adsorbents to bind any migrating chemical. It's maybe not really in line with the goals of the circular economy. So we have to consider. Now let's come to the multi-layer multi-materials. You've heard it before. They consist of different materials, paperboard, plastics, and sometimes aluminum. And they are very hard to recycle. The only fraction which can be recycled is the fiber fraction. And currently, these recycled products are not used in direct contact with food again. So this is also not a real circle in the end. So they are difficult to keep in a circular loop. Now the permanent materials, glass and metals. So I've said that before, the organic contaminants are destroyed during recycling. That's a nice part. Nevertheless, how these materials are collected and separated has a major impact on recycling performance. But for both metal and glass, established systems exist in most countries. Nevertheless, lead content can increase with repeated recycling. And for metal, that's different from glass. Metal is usually not in direct contact with food. So all the metal packaging, the cans are freshly coated. So there we don't need to look so much in detail at the metal composition because it's not the material which is in direct contact. But however we look at it, also here we need to check or to manage the chemical safety of recycled metal and glass packaging to be sure that this one doesn't or is not a source of chemicals that may migrate. So let me conclude. So we all are aware that food packaging strongly contributes to global waste issues. Food packaging is also a relevant source of chemical exposures. Reduction, reuse, and recycling are tools to decrease the environmental impact of food packaging. However, recycling of food packaging increases the risk of chemical contamination, and this is especially true for non-permanent materials. So the current focus on recycling needs to consider chemical safety issues. And let me finish with a citation from Björn Hansen again. If we want to achieve circularity, there must be a merging of the waste and chemicals policies as we would regulating the same thing. I think that's something very important that we really look at the things we are producing and the waste in a similar manner. Let me announce another event. If you're interested to learn more about food packaging and health in Zurich, you're welcome to join our FPF workshop next October. You find more information on the website. And with that, I would like to thank you. Since this is not a live presentation, you're welcome to send me any questions via the email address below or search for further information on our website. Thank you very much.